Hello, Huskies. We're going to talk some more about function notation today. Let's put the fun in functions. This stuff today is really important, but also kind of simple if you just remember one thing. We're mostly going to be looking for the coordinates of points all day. Sometimes I'll be asking for the x values, sometimes I'll be asking for the y values, but you are just trying to locate some points. So you're trying to be a detective, find some clues, locate some points. Okay, just to start off this little warm-up here, it's a little reminder that when I give you function notation like h of x equals 3 halves x minus 5, and then I ask you to find h of 4, it's exactly like saying, way back when, you used to do this all the time. Evaluate this expression, 3 halves x minus 5, when x equals 4. And most of you remember, oh, I have to plug in a 4 for the x and then figure out what this expression is. Yeah, that's the same thing that we're doing here. The directions are different looking because we're trying to be more efficient. So instead of writing all this stuff right here, all we have to do is say this, hey, find h of 4. And that means evaluate the expression 3 halves x minus 5 when x equals 4. That's all you have to do. So let's do it. So that means that I'm going to, instead of x, I'm going to write a 4. And I'm going to figure out what it is. Well, 3 halves of 4, 2 goes into 4 2 times, and so that actually becomes 6 minus 5, which is 1. That means that h of 4 equals 1. So I could write it this way. I could write h of 4 equals 1. But I also want you to remember that normally we say h of x. There's usually an x right here, right? You guys know that. And also, I've told you before, you can replace h of x anytime you want with y. If you're confused, h of x is the same as y. Okay, then, what we've actually just found here is that y equals 1 when x equals 4. And so what we just found here is the location of a point at 4, 1, where the x-coordinate is 4 and the y-coordinate is 1. Okay, if you're confused by that, I hope by the end of the day today that becomes crystal clear, because that's pretty much what we're doing. So let's try another one. Find h of negative 2. Well, there's a negative 2 living in the x house. Usually there's an x there. What does that tell us? That tells us that x must be negative 2. In other words, I'm trying to find this point right here, and I know the first half is negative 2. I want to find the second half. I want to figure out what y is. But the function notation is telling me to evaluate this expression 3 halves x when x is negative 2. And so when I evaluate that, I'm going to get, and you can feel free to type this on your calculator if you don't understand that 3 halves times negative 2 is negative 3, minus 5 is negative 8. Okay, so if that equals negative 8, what did I just find? I just found out that y is negative 8, or that h of negative 2 equals negative 8. And I could think of it like the point where the x-coordinate is negative 2 and the y-coordinate is negative 8. Or I could just think of it in function notation that h of negative 2 equals negative 8. I want you to make those connections that those are actually telling me the same thing. Okay, h of 0, woohoo, we love evaluating when h equals 0, which means that, h of 0, we love evaluating when x equals 0, because when you replace x with 0, then, woohoo, all of this becomes 0, and so it's just equal to negative 5. So h of 0 equals negative 5. In other words, when x equals 0, y was negative 5. And we are talking about the point 0, negative 5, which happens to be the y-intercept, because the y-intercept is the point when x equals 0. And so, hey, there's our x, it equals 0, so our y-intercept must be 0, negative 5. Now, D is going the opposite direction. It's saying, well, what is the value of x when the function equals negative 2? Okay, this time we're looking for x, But remember, we could replace that whole h of x thing with y if we wanted to help us make sense of this problem. Oh, that means we're looking for the x coordinate of the point. This time we know the y coordinate. It's -2 because h of x is the same as y. So, well, how can we figure out what x is? We know that the whole thing equals -2. Right. The whole thing, 3/2 x minus 5, equals -2. Now you have an equation you can solve. Let's add 5 to both sides, and we get 3/2. Oh, sorry, I'm running out of room. I'm trying to squeeze this in down here. 3/2 x equals 3 if you add 5 to both sides. And then there's a lot of techniques you can use here. You could divide both sides by 3/2. You could multiply both sides by 2 and then divide both sides by 3. You could turn 3/2 into a 1.5 and divide both sides by 1.5. However you choose to do it, you're going to get that x equals 2. And so that would have been our x coordinate of this point, that when x equals 2, the whole thing equals -2. Or it's the point where x is 2 and y is -2. Okay. So far, we just did that all algebraically. That means we didn't look at any pictures of it. We were just using the equations kind of as formulas and figuring it out. But the next 4 problems on your classwork, we're going to do it graphically. And hopefully after what we just went through, you'll have a really big appreciation for doing it graphically because it's so much easier. I love these. Okay, here's our first graph. And A says find f of 4. Well, remember, there's normally an x here. So we're trying to tell you there's a 4 in the x house. That means that x is 4. In other words, we're looking for a point where the x coordinate is 4. And what is the y coordinate? Well, let's go to the graph. Here is the line where x equals 4. And where does it crash into my function? Right here. What's this point? What are the coordinates of that point? It's 4, 1. So that means that f of 4 equals 1 because when x equals 4, the y equals 1. So the answer to the A is just 1. That's all you say. Okay, let's do another one. B, f of -4. So I'm going to go to where x, because that's living in the x house. So I'm trying to figure out the y coordinate when x is -4. Where's x -4? It's right here. It's on this road right here. So I'm going to drive up until I crash into my function. Right there. That's my point where x is -4, and I just have to figure out what y is. Okay, y must be 7. So I'm talking about the point -4, 7, that when x equals -4, y, or f of -4, equals 7. Answer is 7. Okay, C, f of x equals 4. Hey, this time x is still living in the x house. That means we don't know x. Do I know x? No, I don't. But I know that f of x is the same thing as y. And so if I want to think about it that way, that's telling me that my y coordinate must be 4. So I have to figure out what is my x coordinate then. What is the point of my function when y equals 4? Okay, well let's go to where y equals 4. Change colors here. This is the line where y equals 4, right? All of this whole line right here is where y equals 4. Well, where does my function hit that? Right there. What are the coordinates of that point? Well, I know the y coordinate's 4, but what's the x? Hey, it looks like 0. And so sure enough, that when y is 4, then x equals 0. So I have to actually write out and say that x equals 0, because I'm not looking for y this time. I'm trying to tell you I know that x must be 0. So sometimes you're looking for the x, and sometimes you're looking for the y. So to help you figure out which one, you should always start by asking yourself this question. Hey, do I know x? Because you're going to check the function notation and see what's living in the x house. Is there something in those parentheses that tells me what x is? Sometimes there will be, and then you know what x is. Sometimes there won't be. Oh, so I must be looking for x. Okay, so let's do D. D is saying f of x equals 5. Well, I don't know x, but I must know y, because this whole thing, f of x, is the same You could replace that with a y anytime you want. So the y coordinate is 5. So let's go on my function. Let's make some room. Holy, whoops. Okay, yeah. Let's make some room. And let's go to where y equals 5. Well, this is the line where y equals 5. And we crash into our function right there. And I'm making kind of a mess of this, but hopefully you can see that it, well, you probably can't see. It does not intersect right at a happy place. It's a little bit farther over. So it's maybe, I don't know, like negative 1.3, negative 1.3. So we would say that x equals like negative 1.3-ish, or negative 1.5, we're estimating. But it's a little bit more than negative 1. Okay, let's do some more. Aren't these great? Do you know x? Look at it on the graph, write it down. No algebra involved. All right, A says find h of x, find x when h of x equals 1. Do I know x? Nope, there's still an x there. That means I must be looking for x. And so I know that the y coordinate must be 1. Well, where is the point on my graph where the y coordinate is 1? Driving along the y equals 1 road, crash, right there. That's where I have the coordinates 4, 1. There's no other place on my graph where the y coordinate is 1, so that must mean that the x coordinate is 4. But I want you to write out x equals 4. That's what I want you to tell me, is that when h of x equals 1, you say x equals 4. I'm just writing this coordinate to help you make sense that we're looking at a point, but really the answer is that x equals 4. Okay, part B, h of negative 2. Do I know x? You betcha. X must be negative 2 because normally there's an x written in there, but now there's a negative 2. So that must mean that x equals negative 2 this time. And I am looking for, instead of the x coordinate, I must be looking for the y coordinate. What is y when x is negative 2? Drive down the x equals negative 2 road. Boom! It's right there. What is the y value? It's 8. So when x is negative 2, negative 8, my bad, y is negative 8. And so you can just say it equals negative 8 because this is the function notation we're looking for right here. I probably wouldn't mark it wrong if you wanted to say y equals negative 8, but you're kind of making more work for yourself because I already have written down that h of negative 2. You can just write, well, that equals negative 8. All right, h of 0. Do I know x? Yep. X is 0. Okay, when x is 0, that's this line. Crash, I hit my function right there. The coordinates at this point are 0, negative 5. So when x equals 0, then my function equals negative 5. And the last one, D, h of x equals negative 2. Do I know x? Nope, there's still an x there. X is a mystery. I'm trying to solve that puzzle. So then that means that this whole thing is the same as y, and I'm telling you that y must be negative 2. Okay, so let's see if we can clean this up a little bit. Let's go to our function and find the line where y equals negative 2. That's this line, crash. That's where I hit my function. And so I'm asking you, well, what's the x coordinate when y is negative 2? I don't know. Oh, it looks like it's 2. So that means that x must equal 2. Okay, we're just going to keep doing lots of these examples until it sinks in, because this is really not difficult. There's not a lot of places to mess up. It's not like solving by combinations where you have to do all this multiplying and adding and stuff, negative numbers. No, you're just looking on the graph, and you're just trying to find the coordinates, both coordinates of a point. You're trying to solve this little mystery. So, g of negative 1. Do I know x? I hope you can hear that I'm asking that same question every time. Do I know x? Yep. X must be negative 1 because there's a little negative 1 living where x usually lives. That means that x must be negative 1. So where does x equal negative 1? Right here is where x equals negative 1. Boom. And I ran into my function at negative 2. So that's the point that I'm talking about. But how do I answer this? I just say negative 2 right here. G of negative 1 equals negative 2. When I evaluate the function g at x equals negative 1, The answer I get out is negative 2. That's what I'm telling you here. Another way you could think about this, like what if I made a table here, x and g of x. Then when x was 0, what was right here, negative 1. How about when x was negative 1? Well, we just figured that out. That was negative 2. How about when x is negative 2? Y is negative 4. How about when x is negative 3? Let's see, where does that hit? Maybe like right there. If x is negative 3, then looks like my y coordinate would have been negative 8. We did this a couple of units ago where you're just pulling the points off of the graph into the table. Well, let's see if that table helps us at all now. Well, part B says find g of negative 3. Do I know x? Yeah, it's negative 3. Well, look right here in this row of the table, I'm telling you that when x is negative 3, y is negative 8. Or that's the point that we found right here, negative 3, negative 8. So yeah, there's a lot of different ways to think about this. I hope you're making connections between the graph and the table and the ordered pairs and the function notation. Let's look at part C. G of x equals negative 4. Do I know x? Nope. X is a mystery. It's still a puzzle. But I know then that y must be negative 4. Hey, look on our table right here. Is there a column in this, is there a row in this table where g of x equals negative 4? Yeah, it's this one. When the y coordinate, or g of x equals negative 4, what was our x? Right there, negative 2. X must be negative 2. Yep, you can totally pull it off the graph. Right there, negative 2, negative 4. It's there. But I'm just trying to, again, make more connections for you. Okay, last one. G of x equals negative 1. Do I know x? Nope, I don't. It's a puzzlement. Okay, well, what is x when y equals negative 1? Again, I could look on the graph, or I could use my handy-dandy table. Looks like x must be 0. Hey, that's not a coincidence. When x equals 0, it's my y-intercept. What's the y-intercept of this graph? Look on your graph. Hey, it's this point right here. 0, negative 1. Yep, the y-intercept is the value of the function when x equals 0. Or, in other words, 0, negative 1. All right, last one on the front. This thing is called a parabola. You're going to study it a lot in 10th grade. So r of x equals 0. Well, do I know x? Nope. There's still an x in the x house. So since I don't know x, I need to go figure it out. And then I know that all of this equals y. So when y equals 0, where is y equal to 0? That's down here. No, just kidding. I'm lying. It's right here. Ha! Sorry. It's too early. When y equals 0, it's right there. But wait, my function hits y equals 0 in 2 different places. That's crazy, but it's not wrong. Your function does hit the line y equals 0 in 2 different places, so guess what you need? 2 answers. In this case, x is going to be 2 different things. X is going to be right there. It could have been 8, and right here, it could have been negative 6. So x equals negative 6 and 8. Those are our 2 choices. Both of them are your answer. There are 2 points where my function has a y equal to 0. One's at negative 6, 0, right here. And the other is at 8, 0, like that. Okay, then the next question says, r of x equals 2. Do I know x? Nope. I don't. I'm looking for x, but I know then that y must be 2. So where does y equal to 2? Y equals 2 is this line right here. So that must be this point and this point. Oh, again, it crosses in 2 places. Is this still a function? Yes. It passes the vertical line test. So what are my points? This one right here is at negative 5, 2. And this one is at 7, 2. So what are my x values when y equals 2? Well, it was either negative 5 or 7. There were 2 of them. That's totally okay. All right, so then look at the next one, r of negative 2. Okay, let's find r of negative 2. So do I know x? Whoops, let's not erase. Do I know x? Yes, I do. X is negative 2. So I'm going to go on the line to where x equals negative 2, and it crashes into my function right here. What's that location? It looks like a 6. Right? The location here is negative 2, comma 6. So when r equals negative 2, then r of negative 2 equals 6, or the y value is 6. How about when r equals 8? Boom, there's my function right there. So it looks like that equals 0. But does that sound familiar? Yeah, we already talked about that up here when x equaled 0 and y equaled, when x equals 8, y equals 0, that was our x-intercept. Right? We had 2 of them. We had 2 x-intercepts because we know that the x-intercept is when y equals 0. Okay, on the back, it's very important that you know I am not trying to get you to solve this problem. I'm just trying to help you understand what the notation is telling you. This is one reason we use function notation. So Fran is making this function, and she has collected data on the number of feet she could walk each second. And she wrote this function, d of t equals 4x, or 4t, there's no x in here. So what does t stand for and what does d stand for? You know, I'm kind of picky about defining variables. So what does t stand for? Why did we use t instead of x? Well, t stands for time. And the units in this problem, she says, it's the number of feet walked per second. So our units must be in seconds. And what does d stand for? The number of feet she could walk. Well, what is that? Maybe we used a d for distance. You could have written it as f or something like that, but this one is kind of helpful because you know you're looking for the distance, and the unit is in feet. Now, remember, I'm not trying to get you to solve this problem. I don't care what the numbers are. I am trying to help you understand function notation by interpreting this. So for the part A says, what is Fran looking for if she writes d of 12? Well, okay, there's a 12 where there used to be a t. What is that telling you? That's telling you that t must be 12, or maybe the time is 12 seconds. And so what are we trying to find if the time is 12 seconds? We are asking how far. We're looking for that distance. How far did she walk in 12 seconds? That's what I want you to write here. I don't care about the answer. I want you to interpret that. What is she asking for? She's asking you to find how far she walked in 12 seconds. Okay, let's look at the next one then. This time we don't know the time. There's still a t there. We don't know the time. But we do know the distance. The distance is 100. So we must be looking for the time. So then our question must be something that says how long. So how long? How long? With 100? What does that mean? How long to walk 100 feet? That's what it means. And again, don't find the answer. I don't care. I want you to know what we're asking for here. And if I don't give you the t, then you're looking for t, and t is time. So I must be asking you to find out how long something took. How long did it take to do what? To walk 100 feet. Okay, so again, on C and D, don't find the answers. Just interpret the notation. Okay, now this big table here is actually something you've seen a lot. But we are trying to be efficient, and instead of writing out 3 different tables, we've just used the same x column and squished in 3 different y columns. So this x column applies to all 3 of these functions. And just to maybe try and clear this up, I could have used all these x's and written -2, -1, 0, 1, and then written a separate table with all my r of x values. So that means that I would have like ignored this column and then used that as my table. That's the R. Or I could have ignored both of those columns and made another separate table with just my B values, like that. And then you could also have just ignored the second two columns. And really, this is something that you've seen before a lot. This table right here, that's just with an X and an M of X or Y. That's like a set of ordered pairs, -2, 0.5. So we're going to just use this table. So far, we have done this algebraically at the very beginning using equations. Then we did it graphically using the pictures, and now we're going to do it on a table. We're going to look for some X values or some Y values. Number 7 says find M of -1. Well, that means I need to use the function M. Do I know X? Yeah, it's -1. So where in the function M does X equal -1? That must be this column and row right here, because it's the M column, there's the function M, and X is -1. So that means that it must equal 1, because when X is -1, then M of X equaled 1. Well, what about R of -1? I still know X is -1, but this time I'm looking all the way over here to the R function, so that must be 12. And B of -1 is still when X equals -1, but this time I'm going all the way over to the function B, which is -5. Now, if we had written out these separate tables, you totally could have used those. Here's when X is -1, R is 12. And here is when X is -1, B was -5. B of X was -5. Okay, so then number 8, this time we don't know X. We know that M of X equals 1, but we don't know what X equals. So I'm just going to write X equals here to remind me that's what I'm looking for. And I'm going to use the function M, and I need to figure out what X is when Y equals 1. So that must be talking about, oh yeah, this same thing. It's just that this time I gave you the Y value, and now I'm asking you for the X value. So X is -1. Okay? Let's do this again without having the tables individual. We're just going to use it on the big table here. And it says, find X if R of X is 12. R of X is 12. Well, all of these say 12. What is X? Could have been that, or that. Hey, do you remember from our mappings, is it okay if all these soccer moms go to the same soccer game? Absolutely. That's totally okay. So that means that we had 4 choices for X here. -2, -1, 0, and 1. Because the Y value, or R of X, equals 12 for all 4 of those. That's totally okay. All right, number 10. Find the x-intercept of B of X. Well, the x-intercept is where Y equals 0. So where is my function B? Does it have a Y equals 0? Or B of X, which is the same as Y, equals 0. I see a 0 right here. So I'm trying to find the X. It must have been -2. So the x-intercept, I want you to write it as a point to remind you that's what it is. And we already knew that Y was going to be 0, so we just had to figure out what the X value was. Now let's find the Y-intercept on number 11. That must be where X equals 0, and I'm doing the function M this time. So here's my function M. I'm kind of just looking at these. And when X is 0, our M of X was 1.5. So that means that X is 0 and M of X is 1.5. All right, a little bit of a discussion on discrete and continuous. We talked about how discrete was disconnected, and hopefully you can find it in a graph. But what about in a story? We have a bunch of choices here. And discrete and disconnected graphs, you have to imagine that you can't have fractions or decimals of something, or there must be a jump in between values. For example, let's look at 13. Susan has a savings plan where she places $5 a week in her piggy bank. Well, what's happening? She puts money in her piggy bank and it stays the same. And then a week later, she puts another $5 in. And it stays the same for a week. And then a week later, she puts another $5 in. That's what's happening to the money in her piggy bank. That's discrete. It's disconnected. She is not sitting there every second of the day putting 1 penny in at a time. It's not going up like that. That would have been continuous. But that's not what's happening with this piggy bank. So when you answer these questions, you're trying to ask yourself, can you have fractions? Can you have decimals? Is it going to cover every distance in between? Can you have pieces? So look at 17 there at the bottom. The number of gumballs and the cost. Well, can you buy 3.14 gumballs? No, you can't buy a part of a gumball. So that's why that would be discrete, number 17. Well, how about number 18? Well, that's just a function. F of x. Okay, I'm having problems with my iPad today. I'm just going to skip right to the homework to number 3 to help you out with that one, and then do a couple on the back. Hopefully it will stop messing up with me. Okay, so number 3, Mr. Bagley has developed a population growth model for the rodents in the field by his house. And he has written this function to model the population of the rodents in the field behind his house. So if I describe this thing, P of t equals 8 times 2 to the t power, first thing I want to know, why P? What does that stand for? Why T? What does that stand for? Well, P is the population of rodents. And T is the time in weeks. Tells you that that's the unit. So that, first of all, if you understand that, it's going to help you figure out A, B, and C. Now, for A, it says P of t equals 128. Well, reading it like that's not very helpful. What if I said the population is 128? Well, that makes more sense because P stands for population. Well, when does the population equal 128? I don't know because I don't know T. I bet that's what I'm looking for. I'm asking here, when are there 128 rodents? When is the population 128? Well, I don't know. Let's figure it out using the equation. So that means that 8 times 2 to the t power must equal 128. Let's divide both sides by 8 here, and we'll get that 2 to the t equals 16, I think. Yeah. Then t equals 4, because 2 to the 4th power equals 16. So on the 4th week, you'll have 128 rodents in your yard. Now B says find P of 4. Find the population when the time is 4. Does that sound familiar at all? We just did that. So this is saying, what is the population when time is 4? When t equals 4. We just figured that out before. It told us there would be 128 rodents on the 4th week. So then if I'm trying to find P of 10, I'm plugging in a 10 instead of t. So I'm going to go 2 to the 10th power and then multiply by 8. Okay, last two I'm going to do here. 11 says find f of 5, and then I tell you at the top what f of x is. It's 5x plus 1. Okay, so f of 5 means I'm going to plug in a 5 instead of x and figure out what that is. So that's 25 plus 1, which is 26. So that means that f of 5 equals 26. I knew x. X was right there. It was 5. So I replaced x with 5. Now number 15 is doing the opposite. It's saying f of x equals negative 94. Find x. I don't know what x is. There's still an x there. It's still a mystery. But if f of x equals negative 94, that means that I can replace the whole function equals negative 94. Because f of x equals all this stuff. It's kind of like substitution. So now we got to solve that. So if I were to subtract 1 from both sides, I'm going to get that 5x equals negative 95. Divide both sides by 5, and x equals negative 19. So when this function equals negative 94, x equals negative 19. All right, good luck with the homework. I know this can be confusing, but it's not too bad. Come in for help if you need some more help.